Hello guys, in this series we will learn how to design water networks using WaterGems and SewerGems. We will first calculate the flows needed and we will talk about the treatment of drinking water. We will talk about the design of RC tank for storage and we will then design the networks using WaterGems and SewerGems. Finally, we will treat the wastewater, designing a treatment plant. We assume here that we have a village of 2,500 inhabitants, 500 apartments, 90 stores, and 590 students. The first thing we need to consider is that we are designing the network for 25 or 50 years in the future. So we estimate the population by the geometric method using this formula where Pn is the population after n years, P0 is the current population, T is the average population growth rate, and n is the number of years between the current year and the year of study. The average population growth rate is estimated as T equals 2%. It's based on the municipality's information, and n will be 50 years. So we can calculate the future population, students and shops. For the average consumption, we can use 150 liters per day for an inhabitant. It could be 100 to 300 liters per day. For a student, it's 15 liters per day, and for a shop, we can assume it 500 liters per day. So the flow average is the average flow for an individual times the number. So we can get the average flow for the village. But this flow isn't the one we need to get from the source, because we need to consider that a percentage of the water will be filtered as brine water when we are treating this drinking water. So to get the flow needed, we will divide the average flow by the percentage of the soft water. So we can see here that the Q needed will be the Q average divided by 0.9, which is the percentage of soft water assumed when we are using a reverse osmosis for treatment that we will talk about later. So this is how we get the flow needed. And also the flow for designing the tank for storage. We should consider the accidental conditions like fire, and we should also take in mind that the tank will serve the village more than 50 years. So the flow for designing the tank will be the needed flow times 1.5. Here we can see the flow chart showing Q average, Q needed, and Q design over the years. We can see how they grow after 50 years from 500 for the Q average to more than 1000 meter cube per day after 50 years. Now we should design the intake pipes. These pipes get the water from the sources to the village. It could be a groundwater source like wells and a surface water source like springs. The design criteria, we will use V as the water velocity in the pipe, and W is the working hours of the pump per day. It could be assumed as 20 hours, and the Q design we talked about earlier. So to design the intake pipes, we will use this Q design. We will divide it by the W, that is the working hours of a pump. So we get the flow for the pump for spring. We are using a spring here to get our water. So the flow is carried by pipes, and the Q of the pipes is the same of the Q of the pump. And we assume that the velocity in our pipes is the 1 meter per second. It should be more than 0.4 meter per second, the velocity in the pipe. And we also assume that our pipes are of 6 inches, and we will then check if these pipes are enough, and we will see how many pipes we need if we use 6 inches pipes. So the area of one pipe is calculated. The flow has the formula of Q equals V times A, where V is the velocity and A is the area. So we can calculate the area needed to have the flow for the design. Then the number of intake pipes is N equal A, that is the area of the pipe needed, over the area of one pipe. So we get N equals 1.47, that is the number of pipes, so we need to use 2 pipes of 6 inches. And then we need to check the velocity. So Q pipes is N times V times A of one pipe, the area of one pipe, and the velocity will be, using this formula, 0.73. So it's more than 0.4, and it's okay. This is how we design the intake pipes for now, from the sources to the village, and this is our first lesson. See you in the next one.